right, now we're going to find all the zeros and rewrite it in a linear factored form. So if they want you to write, oh, here's my polynomial function, 3x to the fourth plus 5x cubed plus 25x squared plus 45x minus 18, and they want you to write the function in factored form, we're going to build 4 binomials. Now that we know complex zeros can exist, and we said we will have, if we have x to the fourth power, we will have 4 zeros. Therefore, we can write 4 linear factors, even if we're going to have imaginary numbers in our binomial. So the first thing we want to do is, just like we did when we found all zeros, graph this first. Now again, as you enter this into the calculator, 3x to the fourth plus da 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 da, remember now this negative 18 means you can have everything from negative 18 to a positive 18. So we may have to adjust our window once you graph. However, because there's a 3 here, you might have your answers from 18 divided by 3 from negative 6 to positive 6. So once you have this typed in, and we're still on our Zoom 6 standard window, we'll go ahead and graph it. We're looking for 4 x-intercepts. All right. Here's my graph. Well, there's 1, there's 2. Okay, 2 are missing. However, stop and think here for a second. Wait a minute, wait a minute, wait a minute, wait a minute. This definitely looks like we have an answer at negative 2. I hit the trace button, I type in negative 2, and sure enough, that's one of my zeros. Now, I'm not going to say I have to go out to negative 18 or positive 18 to find more zeros, because if you take 18 and divide it by 2, that's a 9. So from negative 9 to positive 9 should be the rest of our rational zeros. They're not here. So that indicates to me I have 2 complex zeros here. They're not going to show up as x-intercepts. My next x-intercept, which is right here, doesn't hit the tick mark of 1. It's somewhere between 0 and 1. Now, because of 3 as your leading coefficient, and your 18 has factors 1, 2, 3, 6. Well, we just need the 1 and the 2, to be honest with you. I'm either going to be at 1/3 or 2/3, somewhere between 0 and 1. So it looks like it's closer to 0. So I'm going to type in 1 divided by 3. 1 divided by 3, 0.3s, it gives me a 0. There is my 2 rational zeros. So what we're going to have to do is we're going to have to factor these 2 zeros out with our piggyback synthetic division table to get to our quadratic function, so we can solve those for the 2 complex zeros. So I always save the fraction for last. You got to do a little, just a tiny bit of extra work. So I'm going to do negative 2 into my synthetic division table first. So we bring down the 3, the 5, the 25, 45, negative 18. No terms are missing. Remember, power of 4, you should have 5 numbers across the top. Always add 1 because of the constant here. So 1, 2, 3, 4, 5, we have them all. Bring down the 3. Negative 2 times 3, negative 6 plus 5 is negative 1. Times negative 2 is 2, plus 25 is 27. Negative 2 times 27 is negative 54, plus 45 is negative 9. Times negative 2 is 18, minus 18, guaranteed 0. Again, if you don't get a 0, check your arithmetic. Something went wrong. Extend the vertical line down. And now we're going to put 1/3 through the synthetic division table. So what that means is when you multiply by 1/3, these should all be numbers on the bottom that are a multiple of 3. So I bring down the 3. 1/3 of 3 is a 1. Negative 1 plus 1, 0. Okay, 1/3 times 0 is still 0. Bring down the 27. 1/3 of 27 is 9. Minus 9, 0. So that gives me 3x squared plus 27 equals 0. Since all of these numbers are multiples of 3, you can divide out the 3 from what's left over here. What happened here is that this 1/3 was really 3x plus 1. So again, we never had the opportunity to divide the 3x into our first terms. So now reduce or factor and divide by 3. That gives you x squared plus 9 equals 0. Subtract over the 9. Take the square root of both sides, plus or minus the square root of negative 9. Well, the square root of a negative is the I. The square root of 9 is 3. So here are my two complex zeros. Now, a common mistake that is made when writing this in factored form is, oh, all I have to do is put binomial. So add over the 2, subtract over the 1/3. Oh, add over a 3i, subtract over a 3i. Here's my factored form. Nope, that's wrong. Remember, the first term has to be 3x to the 4th power. And right now, if you go x times x times x times x, that's x to the 4th. You don't want a fraction here. So again, you got to think back when I had x equals 1/3 from my binomial. When I solved it, the last thing I did was divide over the 3. So now I got to multiply the 3 back and subtract over the 1. So my true, what I would call integer binomial, is 3x minus 1. We don't want fractions in our binomial. So that's the real binomial factor, whoops, come back here, that you want to see. All right, so now if you go x times 3x times x times x, you get that leading term of 3x to the 4th, and now that's the proper factored form.